Good morning, everybody. Today we'll be talking about WAEC physics practical. I want to talk about the guidelines that will help us to do well in our physics practical. So, whenever you are coming for WAEC physics practical, you have to come with a good HB pencil, a sharpener, a long ruler, and you have to come with a pen. You don't need a graph sheet because WAEC will provide you with a graph sheet. But please don't forget, when you are coming, come with a good pencil, a sharpener, eraser, long ruler, and a good pen. And in any experiment that we are performing, we have to record our observation. And how do you record our observation? Our observation are recorded in tables. And the tables that we have to make must be well arranged. A table must be well arranged, and each unit should be on each column. You must put the unit of all the observation on the table. And there are some things that you should know, that when reading directly from a measuring instrument, your observation or your reading should be in at least one decimal place. When reading directly from a measuring instrument, your reading should be in at least one decimal place. And when solving for simple arithmetic operation like addition, subtraction, and division, your observation should be in at least two decimal place. And for arithmetic operation like square root, inverse, and logarithm, your observation should be in at least three decimal place. Please, all these things are very important. And okay, look at the sketch table that I did. You can see that there is a unit. I put unit on top of each column, and the one that I read directly from a measuring instrument, it was in one decimal places. And look at that T average, where we did some addition and division there, two decimal places. And also for the period, the big T, capital letter T there, we did it in two decimal places too. While for the square, we actually did it in at least three decimal place. Please, they are very important. I wish I could show us the WAEC practical the WAEC report form, but because of some copyright issue, I will not be able to show us. But please, they are very important. When you are reading directly from a measuring instrument, your observation should be in at least one decimal place. For addition, subtraction, division, and multiplication, you should be in at least two decimal place. While for square root, inverse, logarithm, your observation should be in at least three decimal place. Then in practical, after your observation, then the next thing is to plot your graph. The graph now in WAEC practical, there is a rule that they usually mark with. It is called the ASPL rule. It just means axis, scale, point, and line of best fit. Whenever you are plotting your graph in a WAEC practical, you must take note of these four key important points: your axis, the scale, the correct point, and the line of best fit. So the axis now, you must label your axis, your x-axis and the y-axis. You must label them, and it must be discrete. You should be able to easily recognize your axis. And there's something about the axis that you must know, that your origin must always start from zero. Please, your origin must always start from zero. Don't just be putting any figure that you like. Your origin must start from zero, and you label your axis appropriately, and they should be able to be distinguished. And whenever you are labeling your axis, you must put units there too. I hope that you can see that picture there. That was one of the graph that I constructed. This is just the axis now. Then after the axis, there is the scale. Scale is very important. There are some work that what if you miss it in scale sef, if your scaling is wrong, your work will not be good enough. If your scaling is wrong, your work will not be good enough. So what you have to be careful when choosing what scale for your practical. And the first thing that you should know that what always use reasonable scale. Always use what reasonable what scale, and the scale that what you use, it should be that what your graph will be what large enough. And all use units like 1, 2, 2.5, 5 and 10, and other units that are easily divisible into 5 parts. And don't use odd units for your scale like 37. They actually were dangerous, they are not recommended at all. Always was use unit that you can easily deal with. So please and please don't forget, your scale is very important. Even scale is the most important thing that will be the foundation for all the things that we are going to do in your graph. So please and please, scale are very important. And look at the scale, and whenever you are writing scale, your scale, you must put it on top. So look at the axis there, the 2 square axis and the d square axis. That was 2 centimeter represent 0.5 second square at each interval, and the d axis 2 centimeter represent 10 centimeter at each interval. So what the next thing is what the point, and the point is that whenever you are doing your points, you have to be very careful and be patient. Don't be in a rush. Don't be in a rush. Points are very important. Just try and label your points correctly. The line of best fit. The line of best fit is just a straight line that passes through most of the plotted points. It is not compulsory that it will pass through all the points, but it should pass through most of those points, so that those points that are on the line are still very close to it and are evenly distributed on either sides. And the line is drawn after the points have been correctly plotted. Draw your line after you are very sure that your points are correctly plotted. So look at the line of best fit that I did. You can see that although it was not able to pick every line, and there are some reason for that. It might be because of an experimental error, or just for different reasons. So slope now. In slope, the first thing you should do is choose 2 points from the line of best fit that are reasonably far apart and whose coordinates are easy to read. Then you draw a vertical line from one of the points, and horizontal line from other, so that they will mate to form a big right angle or triangle. And you just read the y coordinates and find the difference between the 2 chosen points. And then you also read the x coordinates and find the difference between those 2 points that you choose. And then you define the difference between the y coordinates by the difference between the x coordinates, and that will be our slope. So you can see the graph that I plotted now. Look at those big triangles that I did now, and that your triangle should be big enough. It should not be small. Let your triangle be big enough. And look at the graph that I plotted, and also look at the slope, just the change in the y coordinates over the change in the x coordinates. And the y coordinate in this graph is changing t square, and the x coordinate is changing d, and we got our slope. And don't forget to put units in your slope. It is very important to always put units in your slope where applicable. So intercept now. So intercepts, there are some times that they will ask you to provide to show the intercept in your WAEC practical. Just produce the line of best fit until it physically cross across the axis at a point. It can be either the y or x axis, and read and record the value of the variable at that point with the correct unit. And precaution are just measures that I was taking to maximize what experimental was error. And we have for some common precaution, like I avoid for parallax error, zero error. For some, for experiment like pendulum, simple pendulum ball that are affected by wind, you can see that what I avoid drought effects. And another general for your precaution is that what you take what readings twice or thrice, and you find what the average. So what precaution what varies due what to what different what practical. So please and please, precaution are important too. And thank you for listening, and please don't forget to like and subscribe.